It's, I think, a very interesting session. Addison Snell, I guess for most people, he doesn't need to be introduced, right? His name has been around in the industry for a long time. People recognize him. And the session is a roundtable on the industry trends between HPC and AI. And I will give Addison the privilege to introduce the people on the roundtable team. So go ahead.
Thank you very much. Hi, everybody. I'm Addison Snell with Intersect 360 Research, and big thanks to Supercomputing Frontiers Europe 2021 and Mark, the organizers, for having me here. I was thrilled that we could put together this roundtable discussion to do a roundup on the first day of presentations, and I'm delighted to be joined by Chiamo Mosegwa and Anders Jensen and Irene Qualters. The three of you, I watched all of your presentations earlier today. Despite it being early here in California, this is really worthwhile content for us in the HPC industry. And you know, I sent a little bit of an outline in advance, but I wanted to be open to discussing a lot of the trends that came up in your talks. And in particular, what I noted was there was a thread of openness across all three of these different conversations, including open source software, open science. And Anders, I'd like to start with you about how you see the importance of open source as we go forward, supercomputing, but also what it does for the community in general and research going forward.
Thank you for that. I think it's paramount, to be very honest. I think the concept of open source fits so well into what we're trying to do, which is to bring the communities together to augment each other's findings and projects, constantly building on what has already been produced, but producing something, achieving something better. And of course, for research and for funding using public money, this is absolutely an ideal model. Not as just as a release model, but the development model of again, one project starting something, another project piggybacking on it, maybe combining stuff from a couple of projects and generating coming up with a new evolution. I really think we gain so much, especially within this domain where there's limited resources. There's so much work to be done. There are so many fields to explore, and quite honestly, there are so many good ideas. So it provides a foundation to test out new ideas, park some, do some in other ways, etc. So I must admit, I'm all for it. I think it fits well with what we're trying to achieve.
I'll tag on to that, stay with you for a second, Anders, because I should have had as part of my question that Chiamu brought up this concept of the construct of fair data, F-A-I-R, data that was findable, accessible, interoperable, and reusable, if I got the acronym right by memory, since I tweeted it a few hours ago. I really is that part. How does that relate to Euro HPC? Do you have any? What are your views on fair data?
So data in general, we're going to see how we're going to build up the concepts around data. Fair is something that's emerging, being discussed. I think it's definitely a model to look at. At the end of the day, data is being generated by one project, just like the results in software. Well, data as well, what gets generated should be available to be used. Data then comes with other complexities in and around what we can use certain data for, and so on. But for sure, this is one of those areas that where Euro HPC also we need to evolve. Right now, we're getting the machines in and defining who can use them. Then we will federate them and need to address issues like this.
And Irene, I'll come to you next on all this with regard to the openness of software and data resources research, because with the Department of Energy, of course, you've got one foot in each side. You've got these open science research platforms, but also matters of national security, which of course have a classified or closed nature to them. So that's kind of an interesting backdrop for this question for you.
So maybe I would also say that on the data side, there are lots of our communities, and I think of astronomers, I think of NASA, I think where the amount of data is so large that the original data may not actually be what is being accessed. You know, so there are all kinds of levels of the data that's been cleaned and you know, anomalies, and so there is a whole issue, as everyone knows, about the data, about what data are you talking about? If you're, you know, if you're getting it, and we have good models where it's worked well. I look at the Large Hadron Collider. I even look at some of the work that's going on now with the interferometers and gravitational wave detectors, where that data is being made available broadly internationally, and the analysis is being by different groups. So I think some of the use cases are actually in play and can be replicated. But you do get into, even before you get into security, you get into health data and control around that. So it's a complex landscape, and
or personally identifying data of all sorts that goes beyond just health. There are all kinds of regulations around that in the U.S., Europe, and elsewhere.
Yes, and they're mostly the same, but but not about what's shareable. So that it's complex, but there are many use cases for which that can be done and can be done well, and we should. And then, as I said, there are harder use cases where data might be. You might have to do derived data or something of that ilk. There's been interesting research that's been done where actually the data stays where it is. I saw this done on the East Coast at a few research hospitals where the data couldn't actually be shared, but you could allow a certain kinds of analytics into the environment to use the data without actually, you know, sharing the data per se. And so I think those schemes also are workable in some arenas where you actually can't share the data. You can allow analysis to be done of a, you know, constrain the type of analysis that can be done to what's permissible with the data. So it's a rich space. I think the codes themselves, having those be open, I think is actually more straightforward and is being done, as was Anders mentioned earlier today, is really a very common model that's embraced quite widely and has a lot of value. I think the area that I talked with Matt about at the end, I think is going to be becoming more important, particularly as we get AI and machine learning into the mix, understanding the workings of the algorithms and the transparency of the AI and machine learning in the results is probably a whole other level. And then, you know, as we move into this really rich arena where there are many different kinds of platforms and the applications hopefully can run portably and with good performance across, the associated workflow, much of that activity will migrates into the system software, and that's also an area. Some of that software we might have to get into the business of sharing more than we do today.
I appreciate that you brought up artificial intelligence and machine learning, and we're going to come back around to that in a second. But first, Shyama, you've been very patient waiting for me to get to you on this. And I wanted to start with the major European and American near exascale and exascale initiatives. At first, it looks like, well, hang on, I'm just trying to build out cyber infrastructure to start with in Africa and get some of this developed. You're not talking about exascale here. And yet it seems like there actually is quite a direct link between them when we look at the openness of the codes, openness of data. How does what you're building out with cyber infrastructure in Africa relate to some of these larger initiatives and help bring it along?
No, thanks very much, Addison and colleagues. I think this is a vibrant discussion to be had, and I'm glad that you tackled it at the very outset. I think the general confusion is, what is open data? As in, are you opening up everything? You've got to think about degrees of openness, so to say, which is why now the great talk is about fair data. You have to identify the type of data you're looking at and look at the model that you want to use for your data. So I think colleagues are spot on. You have to be looking at this different type of data so that you can act accordingly. But the principle really is of openness, the culture of openness, the willingness to go beyond the standard and see and introspect about what can you open up rightfully. And indeed, I think, like I said in the presentation, some domains have demonstrated the value of openness to a large extent. And I think if you saw in my presentation, that not only data, but obviously other artifacts. Now, the problem is exactly this. When you look at what is happening in Africa and where we are, we're a bit behind. Some people are a bit worried about openness in terms of the data set, saying that we're a bit behind. If you open up everything, the big boys are going to come up, gazump everything, move faster than us. But the whole ethos, I would say, is that we have an obligation to participate in the science enterprise by providing some of these data sets, if only, for example, to train these global models, where a holistic set of data is required to provide a global picture. So I think it's incumbent upon the world to have these democratized cyber infrastructures that allow developing countries for also to be able to put onto the map some of that data science to obviously drive science. I think that will be my interjection at this point. Addison, it's a very exciting subject. The International Science Council, through the Committee on Data, CODATA, is doing a lot in this space. And I believe the open science recommendation from UNESCO also provide guidelines to institutions, to countries on how to handle this very sensitive subject. Thanks.
Thank you. And I do want to go back to Irene. You were making a point about AI and machine learning and all the activity we're seeing there. And I'll start with you on this next question, because certainly there's been a huge amount of activity regarding machine learning in high performance computing or supercomputing. And we've also talked about AI augmented HPC in a sense. Where can they work together? But we're also now seeing a specialization of a lot of components that are really geared more for machine learning in particular, especially around inference. And are we seeing a bifurcation between what infrastructure is really targeting machine learning and what's really targeting traditional HPC? So the question is, where do we see these as the same or overlapping or different, not just today, but going forward? And is that a moving target, Irene, as the DOE looks at these resources going forward?
So yes, I do think it is an area of change, and I don't think it's a little early to predict how it'll all fall out and what would be shared, across all sizes of platforms versus specialized. And as we are looking at machine learning and AI, there are certain parts of that space and certain approaches that are inherent in our interest, but AI community writ large has a much broader area of interest. So, for example, the types of research that we're doing now on machine learning and AI, I would say are informed by our knowledge of physics theory. And in some disciplines, that theoretical underpinning doesn't really exist in certain areas of neuroscience and et cetera. But within the realm of physics or material science, we have a pretty good understanding of the theoretical underpinnings of much of what we're trying to model. And so therefore, in some ways, that validates and guides the machine learning and AI approaches that we undertake. And the second piece where this comes in is that uncertainty quantification, because we are trying to really enhance understanding, control, prediction, and make decisions based on that. The uncertainty quantification becomes an essential element from the beginning. So that really means that, we're not as broadly invested in machine learning as others are, because we're really intending to use this for prediction, control, understanding, decision. And that's a subset of that broader space. So I think we're very excited by what's going on in the AI space. It's obviously of interest in many areas. And I think it's a little too early for us to say, oh, this is going to be a specialized space within HPC or not, but there's certainly a lot of innovation today and more to come. And I do think getting the next generation engaged early will help us all.
Anders, this is something you have to look at as part of Euro HPC as well as you plan out these long-term initiatives. What are your thoughts with regards to HPC and AI?
So, what are my thoughts? There's no question that AI will play a significant role, but I do tend to agree with Irene that it may be too early to predict. What's the ratio, if we can call it that. And we're getting equipment in place now, and some of them do have the accelerators that are making great promises in around the AI field. So I'm very much looking forward to seeing what kind of applications when we have it available and when it opens up, that the users will look to run on it, and to what extent AI is going to be part of that. I'm sure there will be a significant AI component, but exactly how big compared to all the traditional scientific applications that is also hungering for computing power, we'll just have to see.
I tend to agree with you both. Unfortunately, as an analyst, I often don't have the luxury of telling my clients too soon to predict that, not going to do the forecast. We have to put numbers into a spreadsheet and eventually publish them, but I appreciate your insights. I'm trying to get some free research from you so I can build it in for my clients. Giacomo, I'm going to edit the question slightly from your perspective, because certainly there's a huge amount of interest and applications building in our AI and machine learning. How does that influence your ability to build out cyber infrastructure for a developing market?
No, I think this is a good debate that colleagues are having. I mean, if you think about it, the traditional HPC workloads are compute intensive, and obviously these newer AI workloads are data intensive, and you find that the systems are by and large non-optimized for such a setup. So it really means that for those who are new in building these systems, they're going to maybe be thinking about this early on when they're designing it, because in principle, you have an advantage of starting anew and thinking about these problems early on. So I think in a way, some of these newer systems that have been developed maybe have to be conceptualized with this in mind. Having said that, you find that for those who already have these systems, the challenge is obviously having to optimize them. And the skills that are required to develop and run these AI workloads on these systems, are non-trivial. And by and large, most organizations do not have the skills, and it takes a lot to train some of the people to do these things. And it's critical that we need to think now about these frameworks that allow us to do things better. I think there's a lot of work on HPC interoperable frameworks. There's a lot of very good work done by companies on deep learning work frameworks, and these are critical because it really facilitates the deployment and running of some of these workloads. I think there's some very good, exciting work on AutoML, which is also, I think, requires a lot of focus in order to make sure that we can now easily, obviously, across the whole pipeline, develop and deploy machine learning models. I think that would be my comment on that one, Addison. We have a fresh start for some of us who are starting out. We need to think about these things bottom up. Thank you.
And I appreciate that. And I'm going to go off script a little bit here just because of the way the presentations today and our conversation is going. I think it's really worthwhile for us to bring up cloud and hyperscale, because when we look at machine learning, really a lot of the very important work that's been done to promote artificial intelligence has come out of the hyperscale companies. And when I say hyperscale, by the way, I mean a lot beyond cloud. Even if you look at cloud providers like Amazon and Microsoft and Google, there's a lot to those companies beyond AWS and Azure and GCP. They have these enormous hyperscale infrastructures, and you also get to companies like Facebook and Apple and Tencent. These have a tremendous hyperscale infrastructures. All of them are investing heavily in AI. They have a tremendous impact on the HPC community, both in terms of steering technology development and in offering high-performance computing in the cloud. So, Chiamo, I'll come back to you on this. When you look at some of the cloud infrastructure, and we also heard about cloud as an architecture from Gaurav today. So, when you look at some of these hyperscale deployments, does that influence the accessibility of HPC and machine learning for a cyber infrastructure deployment in a developing area?
No, that's a very good point, Addison. I think it's a balance, isn't it? You obviously also want to develop your own in-house skills or local skills to be able to develop these cyber infrastructures. Versus maybe accessibility of these compute, obviously through some charging model. So I'm for the balance. I remember attending a session in Harare. The big companies were there, and one of the vice presidents just stood up. The ministers were there and said, "Look, you don't want to be developing any data centers in your countries. Come to us. We've got everything on the cloud." I thought that was a bit amiss because I think it misses the point. That into obviously accessing compute, you must have the capacity to develop locally some skill sets in some of your people running data centers, having some small startups doing stuff. Of course, at the high end, you do need to have access to compute in a democratized manner. So I think it's a bit of a balance, Addison. We appreciate, and there's going to be a convergence where there are probably 3-4 big companies doing these things for the whole world, but there must be a realization that also we need we have a responsibility to develop the skill sets across the board.
Yeah, and
can
there's
I interject a little?
Oh yeah, absolutely. This is a roundtable, so you don't need me in the way. Go ahead, Irene.
So I actually think not just cloud, but edge and sensor developments in the AI space. So I think AI is quite broad, and to the earlier point, some of the areas in which we're using AI are not represented by massive data. We actually have sparse data. And And so the use cases around AI may be diverse enough to support the kind of range of options that we're talking about. Some cloud, some sensor and edge. And similarly, the techniques might be quite diverse depending on the problem suite. So I think it's important not to, as was just said, not to collapse to one paradigm, if you will, a cloud model that, that serves everything, because I don't think it will.
All right, now, Anders, I will go ask you to comment on this with regard to, and this gets political for you and Irene also with at the supercomputing level, because you must run into some people who want you to justify why do we need supercomputing when we have the cloud.
So yeah, both yes and no. At the end of the day, what we're trying to do right now is with Euro HPC is to catch up on a shortfall of compute capacity of real HPC compute capacity, not something that it's the belief that we can get off the shelf in a cloud provider. It's the whole ecosystem that we're building up. So it's not just the hardware; it's the skill sets around it. It's the hosting entities that's running the machines, that's providing the help to the scientists, that's on their codes, etc. The actual compute power is only part of it. So where we of course. So I don't feel what should we say threatened from the cloud providers from that point of view. I think we are two distinct things. Right now we're setting up the ecosystem for HPC. What they are very good at providing is raw commodity compute power at very large scale, and they're very good at it, and that's their model. Whereas as what we're looking at, and as you also saw, I think in my presentations, we're looking to have a diverse set of machines to be able to cover multiple types of problems and to really build up a whole ecosystem with which is skill sets, but it's also research in the different areas that HPC encapsulates. So that we can move the whole ecosystem forward. Yeah.
I do want to get to the topic of skills and staff diversification of high performance computing, but since I have Irene and Anders both here, I would be remiss if I didn't get a chance to ask both of you about processor architectures, because this is such a diverse and thriving space right now that I can't remember a time we've had so much selection. And Irene, you made the point in your presentation. I tweeted it on the fly about the diversity of processor architectures being a boon to us in HPC. As an analyst, I can't help noticing that in the United States, we're seeing exascale efforts that are based on x86, but not outside the United States. In Euro HPC, we're seeing RISC-V, we're seeing ARM. What they have in common is they're all heterogeneous. We're seeing GPUs and other types of attached accelerators, FPGAs, but we're seeing now slightly different emphasis in processor accelerators geographically, not only US versus Europe, but I go to Japan and it's different. I go to China and it's different. So, on the one hand, we've got a lot of choice. On the other hand, we've got a lot of specificity. So I wanted to ask each of you how you see this evolving.
So,
you're each waiting for the other to go first.
Yeah. I guess for me, it's not just about the processor. It really is about that memory architecture. And you see the same diversity going on in accelerators, frankly, with
Yes.
AMD and Intel and NVIDIA. And I really think that we're really just on the precipice of having this much more tightly integrated architecture with accelerator and processor and memory. The other one is what's going on with the memory, which we didn't really talk about too much, but the traditional SSD type of memory, and how now that's, it was always a dream, or some said delusion, that we were actually going to be able to use that as real memory. It never really, but now we're really seeing that come forward. And so, the exact processor may matter a little less in the future, and it may be really that integrated architecture with one or more types of accelerators and the memory interface and how that works and the type of memory. And then, as I said, the other piece that's not receiving a lot of visibility yet is what's happening with I/O from the file system to the basic devices. And that's, so it's, so to Anders' earlier point, kind of the ecosystem, not just the hardware, but the software, the skills that allow that to be us to continue building and advancing rather than porting. That's a key challenge.
Okay, go ahead, Anders.
So on our side, of course, as I think actually the EPI presentation today was a very good summary of where we are. There is a strong drive within Europe to wanting to get back into the microprocessor at a you can say, if I go back when I was a kid, there was quite a bit of microprocessor development within Europe. Over time, we've lost some of that. There's a significant drive and will from the European Union and the countries to get back into that game. That doesn't mean that we will never buy an Intel or an AMD processor. Absolutely not. We just want to also be able to produce our own processors and reacquire that know-how and ability. And we do believe that there's something new that can be brought to the table with a focus on energy efficiency and other good stuff, so that the processor could actually be not just a substitute, but something that adds value to the whole ecosystem. On top of that, of course, we are starting to focus very much on RISC-V, because we see an opportunity to do something similar as what was done in the open source on software on the hardware side. Again, different research organizations augmenting each other's projects to arrive eventually at something that is greater than the sum of each of the projects by employing more the same software model that has been successful, or the same development model that has been successful on software. So we are, as it was, I think it was really well explained in the presentation. There continues to be a focus in and around ARM, which is very much about that whole skill set and knowledge that we and providing something that provides additional capabilities over and above what is available on the market today. It's truly the belief that this will be a game-changing CPU. And then alongside of that, we are investing and investigating the RISC-V path, truly with the aim that is an ISA that is that is not owned by anyone. So that provides a long-term benefit.
I'm glad you mentioned Jean-Marc's presentation as well, and I'm grateful for him there. I'm sorry, Chiamo, did you want to get in on this question as well?
No, I was just gonna concur. I think wearing my computer engineering graduate hat, it's exciting and it's driving innovation. And obviously, one can comment that maybe we need to be looking at non-von Neumann architectures and quantum computing. But I think Jean-Marc's presentation was great. He did mention that these processing units must maybe properly handle modularity, open and agile and data-driven. I thought that was profound. But obviously, wearing another hat regarding cyber infrastructure, I see this as this competitiveness that is providing us with cheaper, processor pricing, and obviously will culminate in obviously democratizing the HPC and the platform. So it's all good. But if you wear a computer science software engineering hat, you worry about the portability of applications. Maybe there's more work that needs to be done on the software layer, including, for example, the example given of having these unified environments. So I think you can see the complexity there, but it's all good.
Yeah, thank you very much. And Irene, I liked your point as well about it goes far beyond the processor to the memory, the I/O. I think fabrics are going to be a really key part of this discussion going forward as well. We're a little light on time, but I do want to touch on this one final topic that came up throughout the day-to-day, because I think it's vitally important and it transitions us well to the last item of the day, which is the student cluster competition, which we're always big fans of, and my partner Dan Olds, our chief research officer, has been involved in student cluster competitions worldwide, and that's increasing access and developing talent for high performance computing. That includes bringing more young people into high performance computing. That involves reaching new or developing geographic areas, which we've been talking about today, and it refers to different types of diversity and inclusion efforts, which can include racial inclusion. It can involve bringing more women into high performance computing, socioeconomic programs. This is something where I think it's easy for us to all agree and say, yes, we need to do better. And then for me, I try to reflect back and say, all right, well, what does that mean for me? What should I be doing better? What can my organization be doing better? And I guess that's the final thing that I wanted to look at here. I am from a relatively small company, but I've got a podcast. I'm relatively visible. I like this topic. I wanted to ask each of you, do you have ideas for what's a specific thing that each of us could be doing better, that we should be thinking about in terms of making high performance computing accessible to more people? I don't have an order of operations on this, so if you feel ready with an answer, jump in.
I can jump in, Addison. I think it's an important topic regarding building our pipelines for innovation, and I think you got to start at universities or even earlier. We have to question ourselves whether each one of us as stakeholders, what role are we playing in that pipeline? And do we look at that pipeline as something that we need to be playing at or being part of early on? I'm saying this, for example, because I think universities are ripe ground to get this started. I think if I had more time in my presentation, I had a couple of slides on our university, industry, government, the co-creation platform that we've created, try to maximize collisions between industry and universities. And I think a lot of big companies now have some sort of programs to engage universities, which is excellent. I think NVIDIA, for example, some very good programs. I'm working with IBM through the IBM Skills Academy, an academic initiative, working with Red Hat through their Red Hat Academy. And these are important interventions to allow early on to engage students while they're at university. And then when it comes maybe specific to HPC, I think it's important to sensitize young minds about not just applications of HPC in general, but try to help domesticate some of these things to their environment. Get them to think about problem sets and use cases that may mean something to them. If you look at citizen science, for example, provides very, very good opportunities for young people to think about how science can be used to solve problems and maybe use some of these platforms in the process to do that. And that will be very, very useful. And the other point that I wanted to appreciate was the presentation on the calls to SMMEs, targeted calls to try to bring in SMMEs to use compute platforms. I think that was very, very instructive. But in general, I also think that this issue of democratizing access to cyber infrastructure is critical because it will actually stem the brain drain, people living in environments where this infrastructure is not there, going somewhere else. And you know where the problem lies. People are going to look for where they can obviously advance. And it's important to help democratize access to some of these cyber infrastructures to be able to provide the diversity that you're looking for. One of the things that we could also do, as I showed in my presentations, is some of the big centers, maybe to pair with smaller centers or universities to be able to cultivate that interest. I think I'll stop there for now, Addison. Thanks.
I'll just mention, since it came up earlier, that very excellent South African student cluster competition team. This was the first year at ISC that they failed to make the podium of the top teams. And it's not that those students aren't incredibly bright, but amidst COVID-19, when everyone was working remotely, the South African team, I think, was disproportionately disadvantaged from having poor connectivity issues to get to the resources that they needed. Working remotely really disadvantaged the South African students, and it gets right to your point about cyber infrastructure. Irene, Anders, anything you wanted to add to that? After that very excellent answer Shyamo gave, I don't know that I would want to. I think he wrapped it up beautifully.
I agree.
Shyamo, were you trying to say something else?
Okay.
All right, well then that's great. We've got 30 seconds left, which is just enough. I'm very good at ending panels on time. I take it seriously. So in my final 25 seconds, I will say I'm excited to see the update on the Warsaw Student Cluster Competition teams. Thank again the conference, the Supercomputing Frontiers Europe 2021 conference, as well as Marek and Alicia for all the support behind the scenes. I was thrilled to be involved this year and really grateful to be on a panel of such esteemed panelists. I'll pass it back over to the organizers. Thank you.
Hey, Addison, don't leave yet. I have one more question for you as the session chair. I think I'm entitled to ask you this question. So here it goes. So you have an incredible amount of experience in the analyst business, probably multiple decades, and you've seen trends come and go. And the title of this session is Industry Trends, right? So the current buzzwords are, of course, quantum, AI, and cloud. And my question to you is, based on your experience, when do you know that the trend is really a trend and not just something that comes and goes in, a puff of cloud, in a smoke of cloud in a short time, lots of press, but, at the end of the day, no cigar. So how do you know, in your experience, to recognize a trend when it's really there?
Thank you. It's an excellent question, and it's one that as an analyst, I will tell you, can be a difficult one, because something can get really hot as a buzzword, and everyone asks us about it. But that tends to happen first before a market really develops. For example, the actual market for quantum computers right now is very small. There are very few of them that actually get sold. You can go and count them individually, right? Cloud computing is probably the topic we've been asked about the most as analysts in my analyst career, going back to 15 years ago. And for most of that time, it hadn't really developed as a market yet. And I mean, it was there, but it was very small. And it really started taking off in 2017. It started growing at double-digit rates and really spiked last year during the pandemic economy, where cloud computing handles uncertainty very well, and it started to take off. I will now, to get to the direct answer to your question, how do we know? really we do a lot of surveys and we talk to end users, and the critical question when we're talking about a market size for something is how much money is someone spending on it. And we've been able to track that with cloud computing. We've been able to track it with artificial intelligence and machine learning. I'll give an example of one that didn't really develop to really make the point, which was going back to 7 to 10 years ago, when all everyone was talking about was big data. Big data, big data, big data, and what's the size of the big data market? And many analysts came out and said this is an infinity billion-dollar market growing at umpty-ump% without really getting a methodology around how many big datas that is and how much each one costs. And what we found was at the top level, budgets weren't changing at all. And that, yes, analytics was a fundamental new workload that was getting built in a lot of places. But when we really looked at spending, people who were doing big data were doing it with storage they already had, servers they already had, people they already had. There were two new things that changed. One was in software, but the software was a combination of free downloadable open source software, which had no effect on spending, writing my own shell scripts and in-house applications, which had no effect on budget or spending, or new modules of enterprise software that I already subscribed to, which had no impact on spending. So as much as there was a lot of new software, there were no new dollars. The only measurable change in spending that we found was on the storage side. People were mixing in more flash and having the same amount of storage total. So there was a little bit of a bump in storage spending related to same number of bytes, but more dollars per byte. So the storage spending took a little bump up due to flash. But other than that, the market did not. So what's the market opportunity? Yeah, there was analytics there, but for anyone advising clients on the opportunity for the size of the high performance data analytics market, like that was a separate thing, that would cause clients to go invest in big data appliances or whole big data divisions, like remember Yark Data, right? Those things all failed. and there wasn't really a separate big data market there. Now, AI hasn't been like that. There is separate money around AI, but I've already given a very long, complicated answer to what was probably intended as a simple question. The answer is we work hard at it. Thanks very much.
Okay. Yeah, so thanks a lot. I think that's great insight.